Hello, hello, hello. This video is about my former graduate student David Pooley. He was an undergraduate student at MIT from 94 to 98 and became my graduate student from 98 to 2003. His PhD thesis was on X-ray supernovae and on X-ray sources in globular clusters. We co-authored 25 journal articles. David was unquestionably among my most brilliant graduate students. He wrote many great software programs which supported my lectures at MIT, for instance 801. Look at lecture 22, where Peter throws a ham sandwich to Mary in orbit around the Earth. Dave wrote that program. Very, very funny. David was also an instructor in my courses, and he met weekly with small groups of my students. They loved him. He received one of MIT's very prestigious graduate student teaching awards. He is mentioned in the introduction of my book For the Love of Physics. You can see his wife Amy about 28 minutes into my third lecture at MIT for NHK TV in Japan. I put small balloons in her hair. My wife and I attended their wedding in New Orleans. He is now a professor at Trinity University in San Antonio, Texas. He has currently published 95 journal articles. His research is still in high-energy astrophysics, dealing with neutron stars and black holes. A large amount of his time is taken up by an approximately $5 billion NASA X-ray flagship mission concept study. He is a member of that committee, which is very prestigious. In this video, which also shows one of his kids, you will see him teach in his usual imaginative way in Zoom mode at Trinity University. All lectures there are now in Zoom mode because of COVID-19.
Hello, my name is Dave Pooley, and I just finished teaching Intro Mechanics this semester. It's always deeply fulfilling to help others appreciate the wonder of physics, but this semester, the fall of 2020, presented challenges since I was teaching remotely. Without access to a stockroom or lab equipment, I had to get creative with materials around my house to help my students see that at its heart, physics is about understanding the world we live in and the phenomena we encounter every day. For some things, I could do that during the live Zoom lectures sitting at this desk I set up in our utility room, just a few feet from our washer and dryer. We actually had to have restrictions on when we could do laundry so that it wasn't noisy during my lectures. But for other topics, I had to pre-record some videos. Here are a few of them. I hope you enjoy them, and thanks for watching. One of the first things I wanted my students to see is that projectile motion in 3 dimensions can be decomposed into 3 separate one-dimensional motions. To produce 3-dimensional projectile motion in X, Y, and Z, I needed help. So I asked my son Henry to hop on this dolly, to which I attached my phone and my wife's phone. I also recorded it with our iPad, which was on a tripod. You can see that from these perspectives, the 3-dimensional motion looks like 2 perfect 2-dimensional parabolas in the XY plane in the upper right and in the YZ plane in the lower right. On the left, with the camera mounted at x equals 0 moving along with the dolly and showing only the y direction, the motion is seen only in 1 dimension. A very non-intuitive concept is that the instantaneous velocity of an object moving in a circle is actually a straight line vector that is tangent to the circle. I showed this by putting a sparkler in my drill and rotating it. The sparks are traveling in circles when they are still attached to the wire, but as soon as they jump off, They follow their tangent velocity vectors in straight lines. Are things really weightless in freefall? To show that they are, I taped an exercise weight to my kitchen scale, along with my phone to record the reading, and then dropped them from a stepladder. As you see, the scale settles in on a negative number as expected, since I zeroed out the scale with my phone already secured. In intro mechanics, we develop equations to describe the parabolic trajectory of point-like masses, much like the basketball that my son Henry threw from the dolly. Somewhat surprisingly, these exact same equations can be used to describe the motion of extended objects, if you consider all of the mass of the object to be located at a certain point, which we call the center of mass. You can find the center of mass of any object by hanging it from a point and tracing a vertical line down from that point. Hang it from another point and again trace a vertical line down. Where those lines intersect is the center of mass, which may not even lie within the physical bounds of the object, as is the case with my carpenter's square. What is amazing is that when I throw this object, and it undergoes a very complicated motion through the air, its center of mass will trace out a perfect parabola. One of the deepest concepts in physics is that in the absence of external forces, momentum is always conserved. There can be many complicated internal forces in a system, but if there are no external forces, momentum must be conserved. This is the operating principle behind rockets. We start with zero momentum. Reactions take place within the rocket to expel fuel in one direction. Because these are entirely internal forces, the rocket must move in the direction opposite the expelled fuel to cancel out the fuel's momentum and keep the total momentum at zero. Gyroscopic motion is one of the most fascinating and non-intuitive topics in intro mechanics. If you put a spinning gyroscope on a stand, it will move around in large circles. This is called precession, and is due to a torque caused by the weight of the object resting on its stand. To prove that, I dropped the precessing gyroscope with my phone secured to a mount to record the motion of the gyroscope. The precession stops the moment I let go of the mount. Fortunately, after all the abuse I put my phone through, the only thing it suffered was a crack in the screen protector. And I think that is a small price to pay to make the physics come alive as best I can remotely in the midst of this pandemic. I hope you agree. Thanks again for watching.